Welcome to Engineering Projects in Community Service for the Fall 2020 semester. I'm Varun Suresh, and I'm going to be telling you a little bit about what I worked on in the Spring 2019 semester for my EPICS project on pool safety. Hopefully, after you hear this, you'll be able to get an idea of what you might work on for your own project or how to move this project forward. Every EPICS project has a community it serves. The community for this project is my community of residents, Maricopa County. It's one of the fastest growing counties in the US as of 2018 and is known for being among the highest in density of uh, swimming pools of any county in the United States. That and its hot summers combine to pose a large pool safety problem for the community and making sure that children don't end up in. The community partner for this activity is Dr. Heather Ross at the School for the Future Innovation of Society at ASU. You can reach out to her for your project in fall 2020 semester to get valuable resources and connections within the community for moving the project further. A little bit about the problem. Children entering home swimming pool perimeters unsupervised are at a high risk of drowning in Maricopa County. While legal requirements exist for child-proofing pools, there is both a failure to adhere to these standards and a high failure rate, requiring novel solutions. A closer look at the impacts of drowning can give a better idea of what an ideal solution would look like. Water-related incidents in Maricopa County specifically impact children, and the drowning averages for our county are 2 times the national average, showing that there's a problem specific to the area. More useful information can be drawn from the data by looking at the causes of drowning incidents and hospitalization, as well as the differences in those hospitalizations seasonally and by fatality. The most important pieces of information drawn out of these statistics for the county are that the majority of incidences that are fatal occur due to a lack of a barrier, and the majority of drowning incidences overall occur due to supervision problems. Also, even with barriers that adhere to legal standards, which are latched fencing, there are still a high number of hospitalizations and fatalities. All of these led us to believe that an ideal solution would target both the supervision problem and the problem of latch failure. The next step from looking at the problem was to develop some specifications by which to judge the existing criteria as well as any concepts generated. The most important of these specifications were the preventative effectiveness and detection accuracy of any concept generated. This means that a solution ideally both prevents a child from getting into the pool area and detects if the child breaks the surface of the pool or enters the water, putting them at risk of drowning. To clarify a few of the criteria here, aesthetic doesn't refer to how good the solution looks, but rather to whether the solution is out of the way or whether it doesn't break up a backyard. Modularity refers to the ability of the solution to be combined with a larger system, such as a home security system, easily and effectively. The existing solutions judged were broken into 2 categories: physical and electronic. The physical systems judged were latched fencing, which is the most common and generally required in Maricopa County, pool safety covers, which cover only the surface of the pool, and publicity campaigns, which exist mainly through SRP, which is the Salt River Project, that works to provide free fencing in areas that cannot or that do not have a high concentration of fences. The electronic solutions include a safety door, which is an alarm door which only works for houses where there's only one entrance to the backyard or pool area. Motion sensors are also experimented with as existing solutions. And finally, there is an existing computer vision system called Poseidon, which exists for public pools. Concepts generated were broken into categories. The first being electronic systems, which were based on supervision. These would include a sensor, a detection method, and an alert. Sensors would include motion, video, water displacement, or biometric sensors. The alert systems could be mobile or cellular, or a physical alarm, like a buzzer. Additional categories include barriers, which are physical, such as a redesigned latch fencing, or publicity campaigns, such as those undertaken by SRP. These concept categories were weighed against each other using decision matrices, and a supervision system was selected to be the ideal solution. Example concepts for the supervision system category include a water displacement sensor and a computer vision system. The selected concept out of the existing solutions as compared to example concepts within the supervision category was computer vision, which would involve using a video feed analyzed by an algorithm in order to detect when children entered both the perimeter of the pool area and if a child were to fall into the water, both of which would trigger different alarms. Moving forward, it is very important that expertise is recruited to the team that works on this. It will require coding expertise in order to build the neural networks necessary and in order to train and analyze data to prove that a computer vision system is feasible and would work for a public pool setting. Prototyping and further research should begin using open source APIs, which are platforms for building machine learning algorithms on. The main one is Google's TensorFlow, which is free to use and download. Other useful resources include Coursera's course on artificial intelligence headed by Professor Andrew Ng, which has a focus on convolutional neural networks, which are the specific algorithm type used in analyzing video for object recognition. It would also be useful to call the researchers or experts at Poseidon for help on how to gather data sets for training, which will be the specific issue in coming up with an alpha prototype. I learned a couple things from my work this semester, and I hope you do too. From working alone on this project, I learned that you have to be honest in your progress and professional in presentation. That is useful advice for when you're working in a group as well, and I hope you learn many things in your journey in EPICS as well.